Okay, so number one, you have to find the common difference because they tell you that it's an arithmetic sequence. So the common difference is positive 5. So with that, you write the next four terms, and that's what it's asking you to write the next four terms, and then to give the explicit and recursive rules. So for the explicit rule, remember, you start off with the first number plus the difference times n minus 1 when n begins with 1. And so here I distributed the 5 here and here to get this. Combine these two, so I got a 3. And so this is the other version of the explicit rule. So either this one or this one. You should know how to get this one, So you could write it like that, but then you should know how to get this one too. The recursive rule, you start off with the first term. F of 1 is 8. And then the next line is the previous term plus 5 for all n greater than or equal to 2. So number 2 is very similar. The difference is negative 3. And so you take 5 minus 3, you get 2, and then you keep subtracting 3 to get the rest of them. Explicit rule, you start off with the first term minus the difference times n minus 1. Distribute the negative 3 to get this. Combine the 8 and the 3 to get 11. So 11 minus 3n, that's your explicit rule. So both of these are okay. For recursive, it's f of 1 equals 8. That's the first term. And then to get the rest of the terms, it's the previous term minus 3 for all n greater than or equal to 2. So for number 3, similar to numbers 1 and 2, you have a common difference of positive 11. And so you add 11 to 7 to get 18, and then do the same thing to get 29, 40, and 51. Explicit rule, this is the initial one, where it's the first number plus the difference times n minus 1, and distribute the 11, combine the negative 4 and negative 11 to get negative 15. So here's the other form of the explicit rule. Recursive rule, you start off with the first term, and then f of n is f of n minus 11 plus minus 1 plus 11 and then for all n greater than or equal to 2. Alright, so number 4, they just want you to write the explicit and recursive rule, but in order to do that, you needed to find the common difference. And you could take any two consecutive numbers to find it. So from 1 to 3, you get positive 2. And again, here's the first term plus the common difference times n minus 1. Distribute the 2. And then combine the 1 and the negative 2, and you get this for n greater than or equal to 1. Recursive rule, this is the first term, f of 1 is 1. And then to get the consecutive terms, you get f of n minus 1, which is the previous term, plus 2 for all n greater than or equal to 2. Alright, so number 5, the common difference is negative 2 or minus 2. From 15 to 13, you subtract 2. So f of n is the first term minus plus the common difference, which is negative 2, times n minus 1. Distribute the negative 2 and then combine your like terms. So here I have 15 and 2 is 17 minus 2n for all n greater than or equal to 1. Oops, sorry. Take it back. Sorry. I made that common mistake. So let me fix it. This would be, okay. Hold on. When the table starts at 0 or when n starts at 0, you don't have this part. Right there, so that's going to change. So it's going to be like this. 15 minus 2n for all n greater than or equal to 0. So that's it. There's nothing to simplify. So this would be the answer, not this part. I mean, there's nothing to work out. That. And then right here and right here. So f of 0 equals 15, and then f of n minus 1, that's the same except this would be 1. So that's the difference. Sorry about that. Alright, so number 6, they tell you that the first term is 20 and the common difference is 15. They want you to find the fifth term of the sequence. So here's the explicit formula. And I didn't distribute the 15, I just left it as is, and I replaced the n with a 5. You could simplify, I mean, you could distribute and then plug in at the end. That's okay. There's nothing, that's okay too. So 5 minus 1 is 4. 15 times 4 is 60. 60 plus 20 is 80. So the fifth term in the sequence is 80. Alright, so number 7 is not arithmetic because there's no common difference. There are a couple of 3's right here, a couple of 4's, a couple of 5's, no common difference. So this is not arithmetic because there is no common difference. Alright, so on number 8, the table only goes up to 4, but notice that there's the ellipsis there, the 3 dots, which indicates that it goes to infinity. So if you notice on the graph, I plotted 4 right here, but then I extended it a little bit more as far as I could on my graph, just to indicate that it goes on, it continues. So for number 20, it says that Matthew earns a salary of $20,000 and will get an increase of 5% each year. What were his total earnings? So it's asking for total earnings over a 5-year period. So that means they want the sum of the 5 years, not the 5th year, but the sum of the 5 years. So we're using the sum formula for geometric series right here. So the rate is 1.05. It's for 5 years, and then the denominator is 1 minus r, so 1 minus 1.05. And I just used a calculator, put it in the calculator. I did this part first. I did 1 minus 1.05 to the 5th power. Then whatever that was, I divided by negative 0.05, because after you just simplify this down here, it's negative 0.05, right? And then after that, I multiplied by 20,000, and it gave me this amount right here. So number 21, it says that Casey is paying $9,600 to rent her apartment, and the rent is going to increase for 5% in the next 3 years. So how much did she pay in the 4th year? So that's going to be f of 4. Here's the explicit rule for her situation. And so here's the initial amount times 1.05 to the 4 minus 1 because n is 4. And so plug it into a calculator and you get 11,113.20 cents. B is asking how much rent did she pay altogether in the 4 years. So that's S sub 4. So the formula for sum is right here. Okay, the initial amount times the quantity of 1 minus the rate to the nth power divided by 1 minus the rate. Again, I went straight to the calculator, plugged everything in, and this is what you get when you do that. The GCF here, the greatest common factor is y, so you get this. And so factors of negative 10 that add up to positive 3 are positive 5 and negative 2. So positive 5 and negative 2, that adds up to 3 and multiplies to negative 10. So then this would be y is x plus 5 times x minus 2. Okay, and that's it. So you multiply the first and last, and you get negative 6x squared. And then you look for a pair of factors that multiplies to give you negative 6 and adds up to negative 1. So it's negative 3 and 2. And this is where you could do the x factor or factor by grouping. I just put them in here myself. That's the first term, one of the factors in the middle, one of the other middle, and then the last term. And so the greatest common factor in the first row is 3x. And then I know that x times 3x is 3x squared. Negative 1 times 3x is negative 3x, and 2 times x is 2x, and then I always check, is 2 times negative 1 negative 2? Yes, so then that's correct. So my answer is 3x plus 2, x minus 1. So number 24, I factored out the y cubed from the 3 terms, and you're left with 10x squared minus 9x plus 2. You multiply first and last, and you get 20x squared. And then you look for factors of 20 that add up to 9, actually negative 9, so that's going to make it negative 5x and negative 4x, so I should have a negative inside 2 here, they're inside the box. Then you put the first term right here, the second and third term right here, these middle ones I'm talking about, and then right here you put in this last term. So in the first row of the box, I can factor out a 5x. Oops. And then 2x times 5x is 10x squared. Negative 1 times 5x is negative 5x. And negative 2 times 2x is negative 4x. And then I check, is this times this equal to this? The answer is yes, so it's factored correctly. So the answers are y cubed times 5x minus 2 times 2x minus 1. So for nat 25, difference of squares, so it's just 3x plus 4 and 3x minus 4. Now 26, if you're just factoring in the real numbers, you would say unfactorable, like there's nothing you can factor, or there's no way you can factor it. But if you're dealing with all the complex number system, which includes imaginary numbers, then this could be factored as 2x plus 5i and 2x minus 5i. So for 27, you factor out a 10, and then you're left with the difference of two squares, and so you have 2 plus 3y right here, and then 2 minus 3y. Alright, for 28, I factor out the greatest common factor, which is 2, and so you're left with 25x squared minus 9y squared, and that is a difference of two squares. So here is how you factor that, and don't forget you always bring down the GCF. Okay. So when you have when you're factoring four terms, the first thing you could try is the 2 by 2 or factor by grouping, whichever one you prefer. And if this doesn't work, then we're gonna have to do the P over Q strategy. Okay. So right here, greatest common factor in the first row is x squared. Oops. And then 2x times x squared is 2x cubed. Negative 3 times 2 times x squared is negative 3x squared, and negative 9 times 2x is negative 18x, and then we see that negative 9 times negative 3 is positive 27, so we bring down the two factors, 2x minus 3 times x squared minus 9. Now x squared minus 9 is difference of squares, right? So you factor it even further, x plus 3 x minus 3. That's for this one right here. So again, number 30 is like number 29. We're going to try this. If it works, then good. If not, we have to do the P over Q strategy. So here in the first one, I can factor out a 3x squared, and 2x times 3x squared is 6x squared, 5 times 3x squared is 15x squared, and negative 1 times 2x is negative 2x. And 5 times negative 1 is negative 5, so that works. So my answer is 2x plus 5 times 3x squared minus 1. Now, if you're factoring over the integers, then this is it, or over the rationals, this is it. You don't have to factor anymore, because this is not a perfect square. Okay? So you could stop right here. So for number 31A, they gave you 2 zeros, but notice I have 3 factors here because the 2i, the i's never come alone. They always come with their conjugate pair. So positive 2i comes with negative 2i. That's why you see that over here. In the next line, I simplified the x minus a negative into x plus 2i. And so now I'm going to multiply the two imaginary factors. So I could bring down the x minus 1. And this is x squared minus, or positive 2xi minus 2xi minus 4i squared. And so here, this and this cancel, so you're left with x squared. I squared is negative 1, and so that's plus 4. And then we have x cubed minus x squared plus 4x minus 4. So this is the function for 31A.